Here it is, folks. The periodic table of elements. It's pretty fascinating to know that everything that exists in the universe belongs somewhere on this chart, okay, or combinations of things that make the universe. So each one of these boxes refers to an element, okay? Simplest form of matter. The smallest piece of an element you can get would be one atom of that. So for example, this one Lego brick represents one atom of the element orange, okay? Or if you were to put it in chemical terms, you would call it O. Sometimes these atoms can't be by themselves, so they combine. And when they combine, they make molecules. So for example, there could be a chemical formula for this molecule, not O, but O2, okay? And atoms can even bond together with other atoms of other elements. Like, for example, we'll take this green dude and we'll put an orange here, we'll put another orange here. Let's add a pop of red in there because it looks cool. All right, ooh, here's some yellow. I like yellow. Let's put some yellow on there, and here's some blue. Okay, so now we have created, through bonding in chemistry, we've created a compound molecule. And it's a compound molecule because it's made up, it's a molecule because it's more than one atom, but it's a compound molecule because it's made from atoms of different elements all bonded together. So this is where we would get those fancy chemical formulas like GRBO2Y, like green, red, blue, 2 oranges, and 1 yellow. Okay? So sometimes these things can be floating around. There's multiple of them. And they're just kind of floating around individually, minding their own business. Maybe they'll bump off each other because they have lots of thermal energy. And we call these things molecules of a gas. Sometimes they're kind of resting together and they have energy, so they kind of like move around and they slip and they slide past each other. That's when these molecules are in a liquid state, okay? And sometimes they're just kind of like staying in one spot, not falling, okay, staying in one spot and it's kind of like vibrating in place. That would make them a solid. But here's the thing. If they, in their solid state, sort of like link together and create a repeating pattern, okay, like this, and then like this, okay, what we've done when we created this pattern of molecules is essentially we've created a crystal. And when you create crystals, okay, and you take hundreds and hundreds of billions of these specially patterned molecules that are all linked together in the solid state, you can get, you know, minerals, okay? So let's take this, let's zoom out. Whew. See that was some good camera work right there. Okay, this is the mineral quartz, okay? To make this mineral of quartz, you'll need hundreds and hundreds of billions of these molecules that are all kind of lined up in this perfect way to make this cool crystal shape, okay? There's lots of different minerals. There's calcite. This dude, if you put it in acid, it fizzes and turns into powder. We've got feldspar, one of the science teacher's favorite minerals because everyone has them in their science classroom. Got this dude named olivine, okay? How about this guy? Talc, super soft, it's slippery. It feels like soap. Okay? This is a weird mineral, okay, called mica. It comes apart like in layers, and it peels like an onion. It's kind of cool. And you can scratch it easily with your fingernail. It's kind of a weird thing. One of the heaviest for its size, okay, making it really dense, we have the mineral galena. Okay, it looks like a metal type rock. Okay, we have fool's gold, pyrite. A lot of people were mining for this and lost a lot of money because it's not really that valuable. And then we've got this boring looking dude. Oh wait, it's not so boring. It's magnetic. Its name is magnetite. So there's all kinds of minerals, okay? And each one of these minerals by itself, okay, can be classified as a rock. So when we talk about Earth's crust, we're talking about it being made of rocks. And all these rocks have this in common, where their molecules are all linked together in these patterns in the solid state. So we can walk around on Earth's surface because all those molecules are linked together in these repeating patterns in a solid state. So this is a rock. It is a rock containing only one mineral. This is a rock. Okay, this is a rock containing only one mineral. Most rocks that make Earth's surface are not like that. Okay, so sometimes you got to look inside the rocks to see that there are many minerals present. Okay, and sometimes when you look at a rock that makes Earth's surface, you can see that it has lots of different minerals that are all kind of linked together. So all of these things I'm showing you are classified as rocks. Sometimes we have rocks that all have similar characteristics. Like for example, this special type of rock, which is a blend of many different minerals. This rock is known as granite. Ah, yes, good old continental crust, granite. We have this, which is made up of a couple different minerals. This is called basalt. Hello, ocean crust. We even have this, which is very fancy. This is called obsidian. So all three of these rocks contain different minerals, and all of them were formed from cool and hard lava. We have these three rocks, which are also made from various minerals. We have sandstone, which is a bunch of sand that got cemented together. We've got conglomerate, which is a bunch of pebbles that got cemented together. We've got shale, which is a bunch of mud that got cemented together. These will be we classify as sedimentary rocks. And finally, we have these types of rocks, like this one called gneiss, okay? We have gneiss, which is what happens when granite subducts but does not melt. It just gets cooked. We have this slate, which is what happens when shale subducts but doesn't melt, it just cooks. And we have quartzite, which is what happens when sandstone subducts but it doesn't melt, it just cooks. And these three rocks are what we call metamorphic. So everything I showed you is a rock. Everything I showed you can make Earth's surface, and everything I showed you has patterned molecules in their solid state, which is why planet Earth is made from this stuff. That's the ingredients. You have those things, you link them together, you can make a planet.